Jason, in last video I told you this wavelength 1 upon lambda equal to r z square into 1 upon n1 square minus 1 upon n2 square derived by Bohr, and also told about Lyman theory, Lyman series. Now for Balmer series, so in case of Lyman series, the shortest wavelength was 912 nanometer and longest was, here it is 121 angstrom, 6 angstrom, longest 912 angstrom, Lyman series. Lyman series wavelength, shortest, longest, all lies putting n equal to 1, n2 equal to 2, we get this, and putting so on, n2 equal to 3, 4, 5, 6, 7 up to infinity, we get this. Now in case of Balmer series, number 2, series is Balmer series. Balmer series. So 1 upon lambda equal to Rz, so for h1 1 upon 2 square upon 1 upon n2 square, where n2 equal to 3, 4, 5, 6, so on. And here these wavelengths were agreeing with experimental value measured by spectroscopy, and the shortest wavelength here is shortest wavelength is 3646 and longest wavelength 63 angstrom, and shortest is 3646, and these are named also as the short longest as H alpha, and next to putting n equal to 2, we get H alpha, putting n equal to 3, H alpha, 4 as beta, and so on, and it will get at infinity. So these are the wavelength of radiation of Balmer series. The wavelength of Balmer series partially lies in visible region, visible light. Not all colors, few colors are there, few spectral lines are there, and because of this formula. Now third series is Paschen series. Paschen. Using equation 1 upon lambda r or 1 upon n1 equal to 3 square minus 1 upon n2 square, where n2 is equal to 4, 5, 6, 7. Both could obtain the wavelength of Paschen series, which all lie in infrared region. These are longer than the visible light. Then comes fourth series, bracket series. Putting in equation 1 upon lambda r 1 upon 4 square or n 2 square, where n2 equal to 5, 6, 7, 8 and so on. Wavelength obtained by, this is formula given by Bohr theory. He obtained the wavelength of Bragg which also lie in infrared region. Dear friend, try to remember that spectrum given in chapter of electromagnetic waves and try to have an estimate in your brain of the wavelength and frequency of different parts of the spectrum: X-rays, gamma rays, visible light, ultraviolet, infrared, microwave, radio wave, etc. Then fifth is fund series. So there, using this equation, n1 equal to 5 and n2 equal to 6, 7, 8, 9. Bohr obtained the wavelength of fund series. So all that way he was able to explain the wavelength of radiation emitted by hydrogen atom. Using his three postulate, he derived the wavelength of radiation, frequency, velocity of electron in orbit, radius of orbit. Now, here, there is one thing which is called energy level diagram of H atom. Atom as a whole is made up of, now by this up till now. A hydrogen atom consists of electron and proton. Proton remain nucleus and electron go around the nucleus in different circular orbit. So energy of electron in another orbit or in any orbit determine the energy of atom. हम बार बार इस्तेमाल करेंगे ये बात. Many times we will be using energy of any atom means the energy of electrons present in it. So from Bohr theory, what is a Venn diagram actually? The graphical representation of energy of electron in different orbits. Of H atom is called energy level diagram of H atom. 1 year this question was asked, what do you mean energy level diagram of H atom? Nobody could write. लिखा ही नहीं गया किसी ने. So representation of energy of electron. Now before I draw this diagram, let us calculate the energy of electron in different orbits. So from Bohr's theory. Energy of electron in nth orbit is En equal to minus 13.6 upon n square electron volt. Z is 1. Now E1 simply comes minus 13.6 total energy, the sum of canonical potential. E2 minus 13.6 upon 2 square. 2 square is 4, it is minus 3.4 electron volt. लगता है बोर्ड थक गया. Minus 3.4 electron volt. You know 1 electron volt 1.6 times 10 to the power minus 19 joule. Remember it. We have done lot of calculation in photoelectric effect. E3 and 3 minus 13 upon 9. 13 upon 9. How much? Nearly minus 1.5 electron volt. 15 9 135 electron volt. E4 minus 13.16 4 square is equal to nearly 0.85 electron volt. 16 8 120. 6, so we can solve it. E5 minus 13.6 upon 25. 13.6 25 0. ये पॉइंट लगा दो पॉइंट 25 125 110 4 जा 100 10 0 0.54 0.54 electron volt. Then E6 minus 13.6 upon 36 electron volt. How much it is? 3 4 ja 13.6 divided by 36 4 6 are 24 2 नहीं जा 3 जा 18 और 10 8 और 2 0 3 8 जा 20 8 जा 48 4 8 nearly 0.38 minus 0.38 electron volt. E7 minus 13.6 upon 49 13.6 upon 49 point of 3 327 2 98 8 4.3 close to 0.3 electron volt. या 0.8 जाएगा 9 जब जाएगा 9 9 36 3 9 4 36 39 कितना बचा 4 और what is wrong there 9 9 ja 81, 8, 9 4 36, 44. Yes. So minus 0.29 electron volt and so on. So one thing I want to explain here. So energy of electron in H atom is either minus 13.6 electron volt or minus 3.4 or minus 1.5. No electron will be in H atom which will have any energy between this or this value or this value. Some discrete energy values can be possessed by electron in H atom, and that is called quantization of energy. But when n becomes large, the difference becomes small, and this is difference in electron volt, and we will not be able to resolve the gap of the energy. So for higher number of orbits, the quantization of energy disappear. This quantization is valid for small number of n. Now how to represent, draw the diagram? How to draw the diagram? देखो E1 था हमारा माइनस 13.6 इलेक्ट्रॉन वोल्ट, E2 हमारा माइनस 3.4 इलेक्ट्रॉन वोल्ट, E3 माइनस 1.5 इलेक्ट्रॉन वोल्ट, E4 माइनस 0.85 इलेक्ट्रॉन वोल्ट, E5 माइनस 0. कितना था वो 0.54, yes, like this total energy. So how to represent? Let us have a scale. Let 1 electron volt equal to 1 centimeter length. So we represent, it is the lowest value of electron, lowest value n equal to 1. So here it is minus 13.6 electron volt. Then 2, the difference is here 10.2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it will be the second orbit. So this value of energy will be according to second orbit of H atom. It will be minus 3.4 electron volt. Then difference is only how much? 1.7. 1.9. So 1.9 is nearly 2 centimeter. So 1, 2. So gap is reducing. N equal to 3. N equal to 4. The difference 0.7, less than 1 centimeter. Less than 1 centimeter. N equal to 4. Minus, it is how much? 1.5 minus 0.85. Then this difference only 0.31. Less than half centimeter. Less than half centimeter. And this gap goes on diminishing, and for large number of energy appear distributed continuously. So this is a representation of energy real diagram of H atom, and here you can represent the difference series also. When electron jumps from this to this, so it will emit energy of minus 13.6, 10.2 electron volt. 10.2 electron volt is energy of photon of ultraviolet region. And this one. And these will represent the transition corresponding to Lyman series. Lyman series. Balmer here like this. Balmer. मतलब going of electron from higher energy to lower energy from n equal to 3, 4, 5, 6 will give the energy of wavelength or wave of Lamides. Oh, Bammer, Paston, and then bracket, and then P-fund, and so on. So you can get different energy levels. You can get this is a called energy level diagram of atom. You can read the book and practice to draw this diagram, because in 12th class exam the question may be asked, draw the energy level diagram of atom. Now I will come to when electron jump from higher to lower energy level, it emits radiation, and the light obtained, the spectrum of light obtained when electron jump from higher to lower energy is called emission spectrum. But when electron goes from lower to higher, so it absorbs some radiation, it absorbs some energy and goes to higher. That is called absorption spectrum. Absorption. When absorption takes place, when electron goes from some lower to higher level, and that energy will be obtained, absorbed in terms of photon when light fall or any other way. Not only the light will fall, we excite electron by passing electric current through the gas, or you can see the absorption spectrum if you pass white sunlight through sodium vapor. Then you will find two dark lines in the spectrum, because the yellow color which sodium emits has been absorbed. So that spectrum is called absorption spectrum. Absorption spectrum may be a line spectrum, may be a band spectrum, may be a continuous spectrum also. I'll discuss more things in next video. I hope you might have got total things about Bohr theory. Now only shortcomings or which facts could not be explained by Bohr theory, I will tell you in next video. Thank you.